Speaker is Ricardo Kirkner. He's going to talk to us about Fabric. Take it away.
Okay. Well, thank you, everybody. I'm going to speak about Fabric and how to use it to standardize the development process. This is about me. Just very briefly, I don't want to bother you with boredom. I'm just working with Python since 2004 and currently employed at Canonical, doing Python all day, which is fantastic. My background is a bit of system administration, machine learning, web development, so just everything a bit. I'm going to talk about Fabric and what is Fabric, why we chose to use Fabric, and how we use it for the development cycle. So let's get on with this. What is Fabric? According to its definition, it's a Python library and command line tool for streamlining the use of SSH for application deployment or system administration tasks. So this definition is evidently extremely clear. So let's go a bit into that and what it is exactly. So the basic naive approach is, as we can see, let's say we want to know the current version of a remote host. So we SSH into it, and we issue a command. Then we read back the results, and effectively, we're streamlining the use of SSH, blah, blah, blah. But this is not Fabric, right? This is plain Python. So let's see how we can use Fabric as a library. Very basic Fabric here. We have a command called run, which will run a command, anything we tell it to on some remote server, which we can see we're setting up in a specific way. But this is not the best way to use Fabric. The best way is to use it actually as a command line tool. So we'll see, we define a function which does this magic run command, and we can invoke that function over the command line, specifying the server we want to connect to, what kind of stuff to execute there. If you call fab-l, it lists all the different commands you have available to run on different servers. So this is proper Fabric, so to speak. A bit old-fashioned, because Fabric changed a lot lately. But it doesn't matter for my talk. So let's move on. Why do we use Fabric? Why do I choose to use Fabric and not, I don't know, build out, make, and sconce, whatever you like? Because I'm talking here about the development cycle and not about deploying stuff to servers, which is what Fabric is really about. So the reasons why I chose Fabric are basically two. This is not me getting to glory or something, but basically laziness. Fabric is Python. I know Python. I don't know make. I don't know sconce. I don't know and I don't want to learn something else for a task which can be easily achieved with Python. The second reason why we chose Fabric is legacy, if you will, because we already had a library for doing deployments to Amazon EC2, and that library was using Fabric because it's used for deployments. So we thought, OK, we could have that for deployments and build out for development, whatever. Let's just use the same tool. So again, it's a bit of laziness. So that's all I'm going to tell you about Fabric itself. And I think I'm going quick because this is basically the halfway of my talk. So let's see how we use Fabric for the development cycle. What kind of stuff do you can't do with Fabric? You can bootstrap your development environment. You can manage your database, run your tests, build binary packages, install them, configure services, manage services, deploy, rollback. Well, anything you can do on the command line, you can do with Fabric, because it's intended to streamline the use of the command line. So let's see a few examples here. The rest of the talk is just examples. So I hope I won't bore you. Bootstrapping your development cycle. First of all, let me backtrack a bit. Why do we want to standardize the development cycle? Basically, if you have a team of developers, everyone has to do the same step everyone has to have their system configured the same way, so you can reduce the differences between the systems and improve all the quality of the stuff you're doing. So bootstrapping is the first step where you want to have consistency. So we want to do some sanity checks, and then we want to install all the dependencies, set up the database, etc. So a typical bootstrapping is about these 4 steps, which we can see we're just doing some sanity checks. Doesn't matter now what those are. And then we're setting up a virtual env, so we can install the dependencies there. We install the dependencies, and then we set up some configuration, we set up some other stuff. So before we go into details, how this is actually implemented, the nice thing about this is when you have this, your developer or any contributor you have just has to do fab bootstrap, and everything magically is set up, configured, and prepared for starting development, starting demoing, whatever you want. So I just want to show a few nice things about this. So in order to set up a virtual env, we have Fabric here. We have a basic Python function, which, well, it will detect whether you're already in a virtual env and not created, but just activated, or if you're not, it will create a virtual env, and so on, and activate it. So with this function, we're not in a virtual env, but we say fab bootstrap, and it will create one activated behind the scenes, and the next command will just be run in a virtual env. So you don't have to do this manually. It just is done for you by Fabric. The activation is actually the way it's recommended in virtual env to do. So you just exec this Python file, and suddenly your process is within the virtual env. So you don't have to do anything else. Creating a virtual env is just as easy as invoking this local command, which will run that command in your local shell, in your local process, which is the way you usually do it on the command line. So as you can see, it's fairly a one-to-one mapping between what you do in the command line and what you write in your Fabric function. So let's see other stuff. Installing dependencies, the same. We just run a command saying pip install requirements, and then in this case we do setup develop, so we get all the rest of the dependencies and what else. And the second function is, I think, maybe the nicest, because that function, so in Fabric you have a function called local, which will run your command in your local machine, versus run, which will run it in your remote machine. But local works at a system level, so it doesn't know anything about your virtual env. So virtual env local is a function which will prepend the activation command, so that anything you run afterwards will be run in the virtual env. So in our use case, we don't use local most of the time. We use virtual env local, which is this function, which will activate the virtual env and then run the command. That way, everything, all the dependencies are detected, etc. So that's about Bootstrap. I mean, I just run fab Bootstrap. It's like the equivalent of make. And it set up all the dependencies in a virtual env, prepared the configuration files, which I didn't show, doesn't matter, and you're ready to go. So the next step you usually have to do is setting up a database, connecting to it, starting it, syncing it. In the case, we're using Django at work, so you need to do syncdb, migrate, whatever. This is a nice trick. For example, we're setting up Postgres server, which by some magic means will gather the configuration of where, what credentials to use, where to connect to, etc. And then we create a Postgres server instance in that location, or we connect. In this case, this is used so that you can create a standalone server inside your branch, so it doesn't depend on a system server, or you could have different branches working at the same time with different servers, different credentials. So this is like a local server. And it's quite nice because if you start your server on shared memory, for example, the tests run much, much faster. So this is basically just create the server, start the database, which starts the server, and set up the database, which will do the syncdb and so on. We have the equivalent shutdown, which will drop the database, stop the server, and remove everything we've created, so we don't leave trash behind. Well, we can see a few more things here. Start the database, just invoke some Postgres command. Set up the database. That's more interesting because we'll check if the database already exists. If not, we'll create it, create all the roles that you need to access it, and finally sync the DB so it's ready for use. Well, create DB runs the Postgres create DB command. As you can see, in this case, we have these env and bin variables and database, which get created by the set Postgres environment, which in turn, I'm not showing this because it's detailed really, but in turn, that function will grab the settings from Django. So you just have to configure your credentials once, and everything magically uses those. So it will create the database, make sure your credentials you're going to use are allowed to access all the things you need, and logging in with those credentials, you don't have to repeat that. Let's move on. Development, that's the main part of why we use this. So you usually want to run a development server in case of Django. You want to do some database maintenance, and you want to run your tests. That's basically what you want to do. So let's look at how you can do that with Fabric. So we defined a manage command, which is a helper because it's really convenient, which runs the Django manage the py, passing in any arguments. So as we can see, running a server is just calling manage run server. As you would do on the command line, you do in Fabric with your function. ResetDB is a bit more evolved, but it basically drops whatever you had, creates it again, syncs DB again, so you're on a clean slate. And test is, in this case, I've trimmed it down. It's basically just running manage the py test, but you can do anything you want. You can load fixtures, you can do conditional testing based on test case selection. I mean, this is a Python function. You can do whatever you want. So how you use this? Basically, fab bootstrap, fab set up database, fab run, fab test. It's really easy. Another thing you want to do usually during the development cycle is some kind of continuous integration. In this case, we are using Jenkins, and to make things easier, well, what do you usually do in continuous integration? You have to bootstrap the environment, set it up, run the test, gather metrics. And we're using a project called Django Jenkins, so it's trivial. We have a function called Jenkins, which bootstrap, resets DB, loads some fixtures, runs the test and gathers metrics. That's done by Django Jenkins. And in Jenkins, the only thing we have to do to have this continuous integration is run fab Jenkins. That's all to it. And finally, well, deployment. This is originally my talk is about the development cycle, not deployment. So I don't really want to talk about this because this is the way you usually use Fabric. Well, I wanted to show something else, but let's go into it because I have time. When you deploy, you have to push your code to some server, prepare the server to run your code, whatever. In our case, we are deploying, at that time at least, we were deploying using binary packages. So our deployment script has to create those binary packages. So let's see how it's done. You have the deploy script, which is a Python function again. I want to stress this enough because it's Python. We all know it. It's easy. So what does a deploy consist in? We create a source package from our branch for any distro series, Lucid, Maverick, Natty, Oniric, whatever. Then you have to create your binary package from that. So you can read it yourself. I mean, it's quite simple because you can name your functions any way you want. So we create the binaries, we migrate the database, we install the binaries, we update configs, run some checks before we commit to the deployment, and restart the services, and magically everything is deployed. So in this case, deploying your server, your app, is fab deploy, and some options to say where. And do some cleanup later. Well, I have more details about how this is done. So building a source package is running a command which, in this case, we're using Bazaar as a version control system, and it has a plugin which called dailydeb. You pass it a branch, and it creates the necessary metadata for building a Debian package. Then using that metadata, you create the Debian package using pbuilder. So it's everything. As you can see here, you have a local function which runs locally on your development box. And this is not using the virtual env, because we don't care the virtual env for building the package. That should be system level. Installing the binary package is just putting that Debian file onto the server, and then running the package and installing that Debian file. So update configuration branch is, it's not important really. You just push a branch, do some symlinking, do some backing up. You can get this from the slides later. Migrating the database is essentially just this. In this case, we're using run, which runs this command, manage.py syncdb, on the remote server. Notice we can't use manage the function, because the function we defined previously is intended to be run locally, and we don't have Fabric on the remote server. So we have to be explicit about path and so on. You could include here the south migrations, Nash Vegas, whatever you use. The preflight checks, we're using a Django app called Django Preflight, which is basically you run it, it does some checks which you can code as Python functions, and if everything is green, you're good to go. Everything you can check database access, cache access, file system access, whatever you want. You code it, it's a few Python functions. And then we finally do sudo. Fabric allows you to invoke a command as root, so we restart Apache, and we're live. That's basically the deployment script. So that's it. Any questions?
You coming up with a question?
Yeah.
Okay.
Thank you for the presentation. I'm working as a Python developer and also a configuration manager. So Fabrics is very interesting for me. My question is it I am able to install pretty much and configure pretty much everything with Fabric, like Oracle?
Well, so the question is, if I got you right, if you can install anything with Fabric, like, for example, Oracle. And the answer is, if you can do it in a terminal, in a console, you can do it with Fabric, because the only thing you would be doing in Fabric is wrapping that command as a Python function.
Okay.
So, yes.
Perfect. Thank you.
I have one question and one comment. The comment is, be wary of using print in these methods when you start writing Fabric. When you get to the point of scale and you have your Fabric orchestration layer running on some machine automatically and you're using print, if you're not capturing standard out, you're screwed. We've gone through and replaced all of our prints with loggers, so now anytime in Fabric we tell ourselves we're doing something, in addition to logging SSH output from Fabric, we're also logging whatever statements we're making in Fabric. The second question is, a lot of your examples look like they're based on 1.1, 1.2. Can you explain the difference we would experience moving to 1.3 if you know what the difference is?
Right. So thank you for the comment. I mean, one of the things we experience with Fabric is when things go wrong, because they do, it's hard to tell why. You have to manually run the command that Fabric was running unless you log it, like suggested, which is a nice suggestion, thank you. And the other difference is this is old Fabric style. This is actually pre-1.0, or roughly 1.0, and a lot has changed. In this style, Fabric will take any top-level function you use and expose it as a task for you to run. As we saw, if you run -L, you get a list of tasks you can execute. In the newer Fabric versions, they have a few improvements, which are quite nice. If you decorate your functions with a task decorator, and only those decorated functions get exposed, so you have much less noise on the command line. So you just see what you want to see, and you're not forced to make private functions so that they're not exposed. Another very nice feature is those tasks. So if you deploy in the old Fabric, you specify 5 servers, they get deployed serially. But if in the new Fabric, you can deploy them in parallel, which is quite nice.
Just a comment. Can you go back to the slide where the activate virtual env is? Yeah, because I worked also with, I also needed to create virtual envs or activate them. And all that script does is to change the path locally, is to just OS environ. So you can accomplish the same thing just calling the pip installer with the path of with the absolute path. And yeah.
Okay.
Yeah, because that's what I'm doing at the moment. I just find out where is if it exists, and then I spawn my Python process with the virtual environment Python executable.
Okay. Yeah, sure. I mean, there are probably several ways of doing this. To be honest, again, this is just worked, so yeah. I'm lazy. It works. Let's move on.
Yeah, because I asked on the mailing list, and they told me that you can do this simply. And another thing, it looks like all the examples are very tied to one platform with hard-coded paths and similar things. Is there a way to make it more multi-platform or more?
Well, it's true this is very tied to one platform because, I mean, I'm working at Canonical, so we use Ubuntu and we deploy to Ubuntu, so it's very tied to that. Making it multiple platform, I guess yes. The answer is, I mean, as long as your platform is supported by Python, everything is free for you to do.
Okay, thank
you. What are the pros and cons between Fabric and Bash scripts?
Pros and cons between Fabric and Bash scripts. Well, as I originally said, they're really equivalent. I mean, there are different ways. Build out, makefile, Bash scripts. They're Fabric. There are all the different ways of doing the same. In this case, for us, the pros were we already know Python. We already had a library which does deployments to EC2. So the pros was we have just one tool, and we use that everywhere for all the developers. So the time it gets a new developer to know everything is less. That's a pro. A con, I'm not sure, to be honest. I mean, it works. Well, you have, sometimes it's easier to just write the bash. But with Fabric, you can deploy in parallel to several servers, which is not what I want to talk, because I want to talk about local development. But I mean, you have one tool. So the con of using bash scripts would be you have more than one tool to cope with.
Hi, thanks again for giving this talk. I've got a couple colleagues that really like Capistrano, but we're really just programming in Python. And so are you familiar with Capistrano? And it seems to have a lot more built-in stuff than Fabric, and I'm trying to find some clear arguments we should use Fabric instead.
Well, I know Capistrano was why Fabric exists, basically, because Capistrano is in Ruby, and when Fabric was created so that we have something like that in Python. I don't know the differences between the feature sets. I would venture Capistrano is around a bit longer, so it has more maturity or more feature sets, but that's just a guess. So also, I'm using extremely basic stuff. I'm not using anything that's new. As said, I'm using pre-1.0 features. A lot has changed, but I don't need it, so I don't use it. Maybe there are features that you need in newer versions. I don't know.
I'll just ask another question since no one else is here. The ability to roll back, do you have an example of where you're rolling back from like when you fail some tests and then it rolls back?
Right. No, I don't have examples.
Do you use it in that way? I guess.
To be honest, we don't use Fabric to deploy. The only reason we have these deployment scripts, and the only place we use Fabric to deploy, was against the VPS. So for continuous integration, for demoing, just have a single command, a simple command to deploy everything and have it launched. Obviously, there's a lot of missing, like configuring Apache What you could do, we're not doing it, you could have a rollback procedure, we should have a rollback procedure, but we don't have one for these cases because it's not production, so it's not necessary.
I was just wondering your thoughts on some of the other types of configuration management tools like, say, Puppet, where it's more like declaring a state rather than actions, like having Fabric do actions. And I know we use both and have tried to find where the line, where one is good to use
right.
and where the other one becomes more useful is really blurry. So just wondering if you had any experience or thoughts on that.
So the question is about what relationship there is between Chef or Puppet and Fabric. And as I understand it, so Fabric and Chef are aimed at a different level of your configuration management. Usually there is a taxonomy of 3 levels. We use something like Fabric Puppet or Chef to get your system into a state where you can start operating on. And because Chef and Puppet are made to keep your system at a defined configuration, so they're declarative and they're reactive, while Fabric is imperative, and it's aimed to do something like a set of statements. So they're different beasts, really. And as far as I understand, they're used in different contexts. You usually do Chef Puppet to get your system bootstrapped to the level, and then eventually you use Fabric to do more command-like statements, like restarting your servers, that kind of stuff.
Thanks.
I wanted to chime in again. So from what I've read, Fabric's moving in the direction of becoming another Puppet or Chef, where it's going to handle the details of provisioning all the way through. If you're still pensive about the use case for Fabric, here's what we use it for. We use Fabric, we use Bodo to fire up an AWS instance. Once the AWS instance is up, we use Fabric to SSH in and install Chef. Once Chef is installed, we use PyChef to change the role of the machine to provision, unprovisioned web server database, whatever we need it for. Ongoing, we use Fabric for maintenance, like stopping services, starting services, running remote commands ad hoc on machines. So it's replaced SSH, like manual SSH for us completely. If we can't serialize the steps and create a Fabric method and then test that Fabric method, we're not going to do it. So that's where it fits in for us. If you're still pensive and you're still wondering where it's going to fit in for you, like Bash scripts, no. Like what are you crazy? Like how are you going to test that? I mean, no offense, but really, how are you going to test that? Here, you mock this call, you test it out, you test it a couple of times, and then you deploy it, and then even then you test it some more. So that's where it fits in for us. It fits as a former sysadmin. This is very nice for me.
Well, thank you for your comment. Yeah, again. I mean, I don't want to avoid questions. I'm very glad you all asked questions, but I deliberately didn't want to talk about deployment because there are a lot of nuisances and issues and delicacies with deployments. And the fact was, you can use Fabric also for stuff that it wasn't designed for, like replacing make or build out, which is what we use it for, and that's what I want to show.
Okay, great. Thanks a lot.
Thank you.